In this lesson, we're going to look at several types of networking devices we can use to build a virtual network. We're going to look at virtual firewalls, virtual routers, virtual switches, and virtual network interfaces. Let's start with a virtual firewall. We all understand what a physical firewall is and what it's supposed to do. Keep unwanted hackers out of your network while allowing the good guys in. When would a company use a virtual firewall? Great question. The majority of its uses are in the cloud or on hybrid networks. The cloud is a highly virtualized environment, so a virtual firewall makes sense. Their uses can be simple, like just controlling ports and access rules. They can also be complex, in-depth defense tools that process data attempting to enter a network. Usually, they'll sandbox attacks to look for the most current heuristic and signature characteristics. Some can even destroy packets inside of a sandbox without you having to do anything. As you can guess, these types of firewalls aren't cheap, but it's estimated that cyber attacks will cost $10.5 trillion by 2025. These new firewalls are a way to mitigate the heavy cost of a successful attack. A virtual router or vRouter works just like a physical router does, except it can handle multiple networks at one time. Again, the majority of virtual routers are used in a cloud computing environment. They work at layer 3 of the OSI stack, and their real benefit is that they have much more flexibility in dealing with multiple networks, which many companies have in the cloud. Nowadays, vRouters are competing with network function virtualization, or NFV architecture. Instead of installing open source software, a vRouter can completely replace the need for any physical hardware at all. A virtual switch or vSwitch allows one virtual machine to communicate with another in much the same way that a physical switch allows physical hosts to communicate with each other. Virtual switches are typically implemented in two different ways. They can be implemented as software that's integrated within the hypervisor itself, which is sometimes called software-defined networking, or SDN. But the virtual switch might also be implemented within the firmware of the hypervisor server hardware itself. Regardless of how it's implemented, a virtual switch functions just like a physical switch. After first coming online, it learns which MAC addresses are connected to each virtual switch port. At first, it floods each frame it receives until it builds a table that defines which MAC address is connected to which virtual port. At that point, it then intelligently forwards frames only to the port where the destination host is connected. Most virtual switch implementations also support VLANs. You can define VLANs within the virtual switch and associate specific hosts with a specific VLAN. But there's a difference. Because hosts aren't physically connected to the switch with a UTP cable, VLAN membership within a virtual switch is defined within the configuration of each individual virtual network interface. Basically, you edit the configuration of the virtual machine and specify which VLAN the virtual network interface should be associated with. It's important to note that in general, a virtual switch's VLAN configuration is actually compatible with the VLAN configuration used by most hardware switches. This allows VLAN information to be trunked from the virtual switch to the physical switch, essentially letting VLANs span both physical and virtual networks. Now, let's look at virtual network interfaces, or vNICs. Within each virtual machine, you can configure one or more virtual network interfaces. These interfaces function in much the same way as a physical network interface that's installed on a physical computer system. They use the same Ethernet standards to transmit and receive frames, and the operating system within the virtual machine also has to load the appropriate driver to support the vNIC, just like on a physical computer. When you configure a vNIC, there are several different parameters you can choose from. First, you can configure adapter emulation. Most hypervisors allow you to define the type of physical network interface that you want the virtual network interface to emulate. This is important because it allows the best possible driver support from the operating system. Really, the goal is to allow the vNIC to work with the default driver supplied within the virtualized operating system, rather than having to manually install an interface driver. Typically, you can also configure the MAC address assigned to the vNIC. Most hypervisors automatically assign a MAC address, but some allow you to manually configure an interface with a custom one if you want. And you can configure a network connection for a virtual network interface since most hypervisors allow you to define many different virtual networks. One last cool feature to bring up is that you can configure a host server with 2 NICs, so that one is dedicated to the regular LAN while the other is dedicated to a segmented, screened network like a DMZ, allowing for virtual machines to use the same 2 NICs in a virtualized way. That's it for this lesson. In this lesson, we learned about different virtualized network hardware. We discussed virtual firewalls, routers, and switches. We learned that these function in much the same way as standard physical hardware. We also learned about virtual network interfaces and how we can use them to complement our physical network layout.